Hello friends, welcome to WebTechSchool. In today's lesson, we are going to talk about given a linked list, how we can reverse that linked list. Consider we have this linked list, then the answer should be our problem is we should print 7, 5, then 5 should point to 6 and 6 should point to 8, 8 should point to null. Okay, so this should be our answer. Consider another example. Let's say we have another linked list. So where 1 is pointing to 2, 2 is pointing to 3, and 3 points to 4, and 4 points to, let's say, null. So we should return the head node where 4 should point to 3, 3 should point to 2, 2 should point to 1, and 1 should point to null. Okay. So this is our problem statement. Now let's see how we can solve this. We will discuss two approaches, one using an extra space and another is an efficient approach. So let's look at the first approach. So in the first approach, I'm going to take a stack. We have the reference to the head node. So this is my head node. Okay. I will traverse through the linked list, and for each node, I'm going to push the element into the stack. So first I'll push 8, then 6, then 5, then 7. Once the head pointer reaches null, so I'm going to stop the operation and I will start popping out my stack. Let's pop it out. So once I am popping out, I will recreate my entire linked list. So I'll first pop out 7 and add it to my linked list. This will be my head. Now to the head.next, I will pop 5. I will add it. Then I will pop 6. I will add it over here. Then I will pop 8 and I will add it over here. So once the stack is empty, that means we reached to our end of our linked list. So it will automatically point to null. Using the stack, we are able to reverse the linked list. But is it an efficient approach? Let's look at its time complexity. So for traversing through the list, it's gonna take big O of n time, where n is the number of nodes in the linked list. Similarly, once the data are pushed into the stack, for popping out all the element in the stack, so that's also gonna take big O of n time. So which will be equal to big O of 2n, which will be equal to big O of n. So the time complexity for reversing the linked list using a stack is big O of n. So what will be the space complexity? Okay, the space complexity, apart from the linked list, we are using the stack, and the stack is gonna contain the same number of nodes what the linked list has. Okay, so for that, the space complexity will be also big O of n. This solution works, but adding an extra space is not an efficient approach. It's not memory efficient. The interviewer or the problem statement may ask you to solve this problem without using the extra space. Let's look at that approach. So I'll clean this up. So this is our answer for the given problem. Okay. Let's now consider a single node 8. So this is our node 8. Our objective is the 8's next element should point to null. This is what it's doing. 8's next element is null. So how we can solve only this node? How we can solve this for only for node 8? So how we can do that? Let's say I will take another pointer. I'll call this as, let's say, previous, and I will call the head pointer as current. Now I want 8 should point to null. Previous is, let's say, null. Okay, so what I can do is I can point this node's next element to previous. So what I am doing, this is my node 8, which is current node, and current node I am pointing it to previous, okay, which is null. The remaining part of the linked list is as it is. So this is where I have 6, and this is where I have 5, and this is where I have 7. This points to this points to this, and this points to null. Okay, so once this assignment happens, what I will do is I will move my current pointer to the next pointer. I will make this as current, and now I'll move my previous pointer to this pointer, to this node. So now previous is node 8. Now we are gonna solve only 6. Okay, for 6, the next element I will again point it to previous. So what I am doing, current.next. So if I'll write this, so current.next, we are adding it to previous, right? So how our list will be now? So rest of the list remain as it is. I'll just write the data element here. Now the current node points to previous. This is what we did. Current.next is equal to previous. Now again I will update my current node. So now my current node becomes 5, and my previous becomes 6. Okay. Now we will solve only for node 5. For node 5, node 5 should point to 6. So we'll do the same thing. Current.next equal to previous. So I'll just update 5, and current.next should be previous. Now this link is broken because now this points to 6, and we'll update current now and previous now. So this will become our current, and this will become our previous. This becomes our previous. We need to solve now for 7. Now 7 should point to 5. So current.next should point to 5. So current.next, what we are doing, to previous, and we'll update current. Now current is over here and previous is over here. Previous is at node 7. This is where previous. So now the current becomes null. So we'll stop our execution and we will return our previous pointer. So the previous pointer, if you look at, so it has already reversed our list. So 7 points to 5, 5 points to 6, and 6 points to 8, and 8 points to null. With this understanding, let's write our code and then we'll do a dry run of the code. Okay, so I'll go to the Visual Studio and we'll use the same class listoperation.cs. So I'll quickly write public static. Let's say we want a reference to our list node, reverse list, and we are gonna receive the head pointer. Okay, so in case the head is equal to null, that means the list is empty, so there is nothing to reverse, so we are simply gonna return a null value. Okay, so if the list is not empty, we want two pointers. We'll create list node previous, so the previous value will be initially it's set to null, then we want another pointer called current, and current we will set it to head. Okay, let's do the traversal on the linked list. So we'll do while current is not equal to null. What we want to do, let's create a temporary node, list node temp is equal to current dot next. So this will hold the reference to the next node, and we'll do current dot next equal to previous. Okay, now we'll do previous is equal to current, and current is equal to temp. Okay, once traversal completes, the previous will hold the last pointer value while current will become null, so we are gonna return the previous value, return previous. Okay, now let's run this and verify, and then we can do the dry run of this. So this is our example list 8657. We will be doing the reverse operation on this list only, so we can do list operation dot reverse list, and in the reverse list we are just gonna pass the head pointer, and then we are gonna receive the list node reverse list. Now let's display it. What we are doing over here, so we are first displaying the list, then we are reversing it. So once the reverse operation finishes, we will again display the list. Okay, the linked list after reversal. Okay, let's run this now, and let me add a breakpoint over here. Let's run it. Okay, now if I go to the console window, so we got back 8. Let's see what is the problem. Let me close this window and let's verify. So this is where the problem is. We are getting back reverse list, but we are passing head. So I'll just pass the reverse list in the display list. Let's start. And if you look at now, so the linked list before was 8657. The linked list after reversal 7568. So we are successfully able to reverse the linked list. Let's start the dry run of this code. So what we are doing, the first line is if head equal to null, then return null. So our list is not null, so it's gonna come to line number 90, where we have two pointers. One is previous, so previous points to null, and another pointer is current, which is pointing to head. So this was our head, so this is our current. So we are doing, as long as current is not equal to null, then temp equal to current dot next. So current dot next is 6, so this will become our temp. Okay, then current dot next is equal to previous, So current.next is equal to previous. So this will become this, and we'll break this like we explained earlier. Now the next line we are doing previous equal to current. So previous will become the current. This will become previous. Now current will become temp. Now current will become temp. This will become current. Now again the loop continues. So temp is current.next. So this will become temp. Current.next is equal to previous. So this will become previous. Then previous equal to current. So before doing that, let's break this. Previous equal to current. So this will become previous. Okay, and current will become temp. So current will become temp. This will become current. Okay, again the current is not equal to null, then temp will become current.next. So this will become temp. Then current.next is equal to previous. So current.next, now it will be previous. Okay, now previous equal to current. So previous will be current. The next line is current equal to temp. So current will become temp. Okay, again if the current is not equal to null, then temp will become current.next. So this will become temp. Now temp is null. Then current.next is equal to previous. So current.next is equal to previous. Previous equal to current. So previous will point to now current. Okay, now current is equal to temp. So current will become temp. So now current points to null. So our loop ends over here. Now finally we are returning the previous pointer. So the previous pointer points to 7. So now the previous pointer has reference to 7, 5, 6, 8, and 8 finally points to null. Let's calculate the time complexity for it. Time complexity would be, we are traversing each node only once. So it will be big O of n, where n is the number of node in the linked list, and the space complexity will be constant as we are not using any extra space. We are using the same linked list to solve our problem. So that is it for reversing a linked list. I will post this code to GitHub repository and you can find the link in description. Please subscribe to support us, and thanks for watching.